I'd like to introduce our next presenter, Rafael Machado. He is with the Flex Institute of Technology. He is a computer engineer and works as a researcher and professor in Brazil. He's been working with manufacturing and hardware diagnostics for the last 8 years. He also has a mastering degree in computer science, focusing on making the pre-OS environment accessible to the visually impaired people.
Okay.
Come on up. Yeah, he will present today on UEFI topics for manufacturing efficiencies. Thank you.
Okay, thank you. Hi, everyone. First of all, I'd like to say thank you for the organizers of the event for the opportunity to talk about some subject that normally people forget to think, okay? That's the relation between the UEFI environment and the manufacturing. So we'll try to show you the things that we are looking and the problems that we have and we face on the manufacturing, okay? So here's the agenda. Since this is the first time we are here as presenters, I'll give a quick introduction about the company so you know what we can do to help the environment and the community, okay? So I work at FIT, that's this research institute in Brazil that is part of Flextronics environment. So we do all the research and patents for Flextronics clients, okay? And I'm also professor at Facens, that's a university there. We are near São Paulo, a city named Sorocaba, okay? So our knowledge, since we work with Flextronics and its clients, is related to manufacturing. So a simple view of a manufacturing process would be something like this. So at the beginning, you have the ODMs creating new technologies and new kinds of devices that you can use on equipments. You have the OEMs creating new platforms for the people. Some of them use manufacturing services from other companies. That's what Flextronics does. And then you have the part of selling and the marketing of the equipment, okay? So this shows that everyone needs to work together to have a product that really is successful on the market, okay? And the manufacturing process by its own has a lot of challenges to be passed, okay? So when you need to create a big number of equipments, and by a big number, I'm talking about thousands and sometimes millions of equipments, so you need to do it fast, you need to do it with high quality, you need to do it with low cost and without waste as much as possible. Okay, so we see that it's not a simple task to be done. Okay, so you need to create equipment that are reliable, so the end user will be happy after buying it. And there is a field on the engineering that is focusing on this. That's named reliability engineering. Okay, and the basis of this kind of engineering is this curve. They name it bathtub curve, that shows how a given equipment, a population of equipments will follow during its life, okay? So there are 3 phases. Some equipments will fail just after they are assembled due to some problems with the ICs and these kind of things. After that, the equipments that are working together, that are working correctly, they are sent to the users. And the problems that are faced are related to users using incorrectly the device or dropping it. So some devices will fail in this phase also. And at the end, you have the equipments that will stop to work due to the wear out, since they were used for a long period of time. Okay? And to have an equipment that really works and the users really rely on it, everyone needs to work together. So the ODMs need to create devices and firmware that are reliable, so the OEMs can create equipments that use it. The BIOS need to be reliable also, because we'll see on the next slides that's really hard for applications to detect problems that are related to firmware and to hardware. Okay, so everyone needs to work together so the manufacturing can create equipments that will work for a long period of time. Okay? So to get to a point where you can rely on as much as possible on the equipments, during the manufacturing, we have some tests that are done, okay? Until you reach this point where the equipments that have problems are removed from this population. Just the equipments that will really work are sent to the end users. Okay, so there are different kinds of tests that can be done. Okay, they are named burn-in tests because they try to simulate an user using it for a period of time. Okay, and why this is needed? This is needed because research and studies shows that most of the equipments fail on the beginning of its life. Okay, so these stress tests try to remove these equipments. So the user will receive an equipment without the possibility of opening the box and have an equipment that doesn't work, or getting an equipment that will work for some days and after that stop to work. Okay? And to execute these tests, the UEFI environment is really attractive because there are some advantages when you look at the UEFI environment when compared to a common OS environment. So the fact that you don't have the difference between user space and kernel space is a good point because it's easier to create diagnostic tools at UEFI environment. Okay, you don't need to fight against the operating system because of the resources of the platform, so you can test more parts of the platform. Okay, it's cheaper because you don't need to pay license. In the past, companies used to pay serial codes for the OS just to be able to produce the equipment and execute tests at the manufacturing process. And it's faster to boot also, currently. Yeah, so it's much faster to enter at the UEFI shell than having an operating system, booting it, and then executing the diagnostics. Okay? And the evolution of the UEFI specification has been seen with really good eyes by the manufacturing guys. So since version 2.0 until version 2.7 here, we have the protocols related to media access. Different protocols were added, and this is really nice for the manufacturing because you can test more kinds of devices. Okay, so now we can test NVMe devices using the pass-through protocol. We can test the SD devices. So as much protocols you have, the better for the manufacturing because you can test more kinds of devices without needing to do magics, okay, because the drivers are embedded on the BIOS, okay? And other protocols that are really important for the manufacturing are related to network also. So here is another comparison. So with version 2.7, you can test if the Bluetooth hardware is working correctly, IPv6. So you can test most of the things at pre-OS environment, and this is really good for the manufacturing, okay? But there's one thing that's really complicated for diagnostic tools, that is differentiate when a problem is caused by a firmware issue or a real hardware issue. Okay, and this is a nightmare for the manufacturing because you can stop a manufacturing line because of a firmware issue. The users will not know, the users in this case is the manufacturing guys, okay? They will not know if the hardware has real problems or if they need to update something, okay? And a firmware issue can also break a system on the same way a hardware issue does. So I have some examples here that are real examples that we see on some client, okay? I cannot say the names, but we have seen this. The image is not so easy to understand, but here is the analysis of ATA protocol packets that was sent. So the first box represents a device that works correctly, okay? And the second one represents a device that fails to process a packet that was sent. We can see a red box here, the status with error. And after receiving this from the manufacturing guys, we start to analyze, and we see that the problem was that one bit at the packet, one bit that's filled by the driver from the BIOS, was being set incorrectly. So on a system that it works, it was the LBA mode bit was set as 1, and in these devices, LBA mode was set as 0, and this was causing the packet to fail to be processed, okay? As a result of this simple error at a firmware, 32,000 storage devices were failing at manufacturing, and this caused a big delay because until we really understand the problem, the manufacturer needs to replace these storage devices by other devices, okay? And this is really bad for manufacturing. But the good point is that this was detected during the manufacturing process. So the diagnostic tools, in this case, eliminate 32,000 possible calls to the call center that are also expensive for the OEMs in this case, okay? So this is one example that a firmware issue caused real problems on the manufacturing, okay? Other things that are really hard for the diagnostic tools to understand is when a given hardware is failing because it has problems, or if the protocol should not be there. So here's an example of a desktop that was connected to a common LCD display, and the absolute pointer protocol was there. So when you design a diagnostics application, you check if the protocols exist, and you try to access the hardware, but in this case the protocol is there, but it points to nowhere. So if instead of having an application with several whitelists, for example, this device should have touch support, this and doesn't, so it's really hard for the application to know if the hardware has problems or if the protocol is there but it's pointing to nowhere. So for the manufacturing, the firmware and the BIOS needs to be reliable and work correctly, okay? In this case, the result is that it's hard to understand if this represents a real problem on the hardware or not. This may cause some delays on the new product's introduction to the manufacturing, because until you reach the real scenario, understand the problem, you cannot continue producing it, okay? Because you may use parts that are not reliable, okay? So these are some problems that we have seen. There are some problems, examples. These protocols that point to nowhere are one of them. Another problem that we see on the manufacturing is that most of the BIOS have drivers that are not needed, but they are on the BIOS image. And this is really bad for the manufacturing, because during the process you need to download BIOS updates to update the system and then continue the process. So if you have a lot of drivers there that are not needed, you are expending time. And in manufacturing, that's the moment where all the research and things are converted into money. So if you are wasting time, you are wasting money, okay? And we have seen some problems with the network stack also, especially PXE, but when the platform is set as UEFI only, so PXE used to work correctly with legacy mode enabled, but there are some platforms, some BIOS that starts to have problems when you set the platform as UEFI only mode, okay? So the network stack is a problem that we have seen also. In fact, I forgot to put one example here. One of our clients have a problem, they still have this problem, because they use it to have the PXE connected directly to the board using the wired network, but the newer platforms are coming with wireless only. So for the manufacturing, they use USB dongles to have the wired connection available again. But in the past, without the dongles, the download used to happen in 30 seconds, and now it takes 8 minutes because of some problem with the USB driver and these kind of things. So BIOS problems, drivers that are not well designed, cause real impact on the manufacturing. So if you are working on drivers, please remember the manufacturing, because we need this to be fast and reliable, okay? So simple checklist. If you are working with some drivers or some platforms or BIOS, please follow the specs that you are intended to follow, because the diagnostic tools will consider that you follow it, and we will try to do the same way, okay? Please remove the things that are not needed from the BIOS, because it will be faster for the manufacturing. There is another thing that everyone is saying now that's related to the attack surface on the manufacturing. Manufacturing is being seen as an attack vector right now. So if you have a lot of drivers there that are not used, they can be used for bad things. So please remove things that are not needed. We will be safer, okay? And remember that the network is crucial for manufacturing. So please do network stacks that are really reliable. Mathi's work that was presented yesterday is one really good example of network improvement that's good for the manufacturing, because using a multiprocessor network stack is really good for manufacturing, because you can download things faster. Okay, so these kind of initiatives are amazing for manufacturing. We'll definitely try to use it, okay? Another thing that we would like to show you is that the manufacturing has some desires that I collected with some guys there that are related to new protocols to be added at the specification. Okay, so one of them is the GPU protocol. So the manufacturing can validate the network, the video cards at pre-OS environment. It would be faster for the manufacturing. Okay, this would be really nice to have. Battery protocols also to check the health of the battery and their status. Multi-touch is another thing because currently at the spec we have just the absolute pointer. So when you have multi-touch displays, you cannot test if all the points are working on the hardware. There's another item that is the audio support. I put here the link of my GitHub because my mastering thesis, as Stefano mentioned yesterday, is related to create the basis for ProOS accessibility. So we already have some code that we can work and create some protocol for audio support. If you think that accessibility is not that important, we can use the audio protocol for the manufacturing. So if you're thinking just about the money, the manufacturer would really be benefit by the existence of this protocol, okay? So we can work on that. And another protocol that the guys would really like is related to the fan and the cooling systems to be able to change the speed and check if everything is working correctly, okay? And one of the dreams from the manufacturing, this has a separate slide because they would really like this, is to be able to use wireless networks for the manufacturing, okay? I think there is one company that did something like that, but there's not a reference code that everyone can use. So if you have the capability of doing PXE or HTTP boot over wireless networks, it would be really good for manufacturing because to create a new manufacturing line would be really faster. You don't need a lot of cables and a lot of possibilities of failure, okay? So it's a fast presentation. I'd just like to give you these points so we can start to talk about it. So if you have some questions, please feel free to ask.
On the network front, the Wi-Fi, do you guys plug in a adapter card or what do you guys plug in to get the Wi-Fi?
To get the Wi-Fi?
Because you mentioned a Wi-Fi connection, most systems don't ship with a Wi-Fi.
Okay, on systems that are just Wi-Fi, we have a USB dongle that is connected to the USB port, and this device exports a wired connector so you can plug it on the network again. And this is presenting some problem for the manufacturer because it's really slow to have the download over this USB interface, okay? More questions?
See, doesn't adding protocols for things like batteries and fans, which aren't needed for a normal boot, but only for manufacturing, doesn't that kind of go against the desire to shrink the BIOS and to reduce the attack surface?
Maybe, yeah. Maybe, yeah. We need to talk about this because manufacturing needs this. So, and at the OS, the guys do applications that can access these kind of things. So at one level, you have this kind of support. So at manufacturing, we need this, but we need to talk about it. Okay? Because what happens at manufacturing that sometimes you need to do some parts of the validation at ProOS and go to Windows and do some updates and go back to OS. So these reboots and context changes from OS to ProOS are really heavy for manufacturing. Yeah. But we can talk about this. More questions? I'll be around. If you have any questions, just let me know, okay? I think that's it, guys. So if you need to contact me,